Okay. All right. So central angle, guys. We're just gonna okay. We're jump right in. Okay. So central angle, just an angle that has the center as its vertex, right? That's that simple. So CEW is a central angle. So angle COW, so cow, that is a central angle. So is angle ROC. By the way, what would the measure be of angle ROC?
130.
Yeah, because it has to form 180, right? Okay, so those are central angles where the center of the circle is the vertex of the angle. Okay, an arc is just simply a portion of a circle. That's all it is. Just a portion of a circle. So examples would be, and we'd write it like this, like CW. You put a little like arc symbol or crescent symbol on top of it. Or another example would be like CR. CR is an arc. So if I get a highlighter out, yeah, so like CW, that's an arc. Or if I go blue, RC or CR, whatever you want to call it, that's an arc. So those are examples of arcs. Um, and you're always supposed to put that little crescent symbol on top. This is just a bad print. It's supposed to show this, just so you know. Now, what do you think the M stands for when we have M next to something? So we want to find the measure of it. So a full circle, we know a full circle is 360, right? Full circle, 360 degrees. But we don't have a full circle for CW, right? In fact, actually, it's a fraction of a circle. Now, we don't have to determine what the fraction is, but we do need to determine the measure of the angle. The measure of the arc is the same measure of the angle that's central to it. So COW is central to that arc, right? Because it's obviously at the center. So if that's 50, then we call this 50 as well. So the arc and the central angle always have the same measure, just so you know. So CW is 50 degrees. Now the length is a different story. I need the radius. I don't know the radius. That's a different story. We'll worry about that later. How about CR? 1/3. Yeah, that's it. It's just that simple. So it's very, very straightforward. Now things will get messy. Correct. How many degrees the arc is? Things will get messy when the vertex is not at the center. When it's somewhere else, you'll get, and that's why we have the formulas on that other page that I showed you guys yesterday. We'll worry about that later in the unit. Okay. Congruent arcs, obviously, they're the same measure. Fine. Okay. Minor. Minor is anything less than 180. Semi is exactly 180. Major is more than 180. Hopefully that's intuitive. And always you're going to use the endpoints of the arc to name it. So notice I did CW, CR. If it's a major, we like to use 3 endpoints to call it, to name it. So we would use 3. So let's look at some examples right below. So name 2 minor arcs, name 2 major arcs, name 2 congruent arcs, blah, blah, blah. We'll do this together. So minor. Would you say that's minor? Yeah, sure. So you just say arc and EP as well. Yep. Those are both minor because they're both less than 180. That's all. Okay, majors. It has to be more than 180, and there's a lot of ways you could say it. Um, I would say this actually. Um, actually, hold on a sec. What do you say, Faith? EPT? That works, yeah. You have to use at least 3. You could use more if you want to. You have to use at least 3. Um, so arc EPT. So notice I didn't say arc ET because ET looks like it's less than 180. And that's confusing, right? If you say ET, the implication is going to be minor, right? So whenever you use 2 points, the default will be a minor arc. So if you were to tell me ET, then you're telling me this. You're not telling me this. You have to use that third letter to make it major, just so you know. So it's a naming thing. SPT is a great one. Yeah, I like that. Arc at SPT. You guys said SCT, that could have worked also. But if you're saying SPT, SPT, so let's connect it. Because if you said ST, guess what? ST is going to be minor, right? You can't say ST. That's going to be confusing. That works. So you could, if you want to do 4, that's fine. You could. I would accept that, and that's fine. Yeah, go ahead. Not necessarily. Depends what you're saying is congruent. You'll see how we'll do that in a moment. Okay. So 2 semicircles. Well, that's pretty easy. SCP is a semicircle, right? What else is a semicircle? STP.
The semicircles have to be connected.
It does say they're used, their name using its 2 endpoints and 1 additional. Yeah, you do. Yeah. You do want 3. So you use the endpoints of the diameter, because S and P are the endpoints of the diameter, right? And you use an additional point in between S and P, right? Okay, name an acute central angle. So now we're doing angles, not arcs anymore. What's an acute? Acute means less than 90, right?
Yeah.
I love it. EOS. Perfect. Good. 2 congruent arcs. That one's a little tricky. It didn't really.
STP and S.
Yeah, the 2 semicircles are going to be congruent, right? Yeah, so let's just do that. Yeah, that's true. Why not? Yeah, because they didn't really tell. Like you could say SO, like ST here and ES, but we don't know, but they didn't tell us much information. So I think to be safe, let's do 2 semicircles, and then if TOP. So let's draw TOP. So that'll be 110 degrees. Then PET arc. Let's also say an arc. That's confusing. So arc PET. Yeah, do you guys see why that's 250? Yeah, because arc, so angle TOP intercepts this one, right? If it's intercepting this one, this is 110. Therefore, this has to be 250 because this is what's left over. Correct. Okay, we're good there? Yep. Okay. All right, so that's just more just getting comfortable, familiar with the naming and identifying those things. Okay, next up, arc addition postulate. So just like I had angle addition postulate or single segment addition postulate, it's the same thing. If you add up 2 arcs, they add up to the bigger arc, right? So yeah, and by the way, you're supposed to have these little symbols here. So in, erc, and ken. Okay, so for measure of arc IN. Well, first off, let's do this before we get too carried away. I'm going to say this is 50, right? I'm going to say this is 100. And I know, I don't know if I can assume that. I mean, it looks like SRE is 90. You know what? No, because you have to be told that. You know, we'll just do it. I'll just tell you it's a right angle. Angle SRE. I'll just add that because you really should be given more information. I don't like that, but well, that's a diameter for sure because it's going through the center, right? Well, together, but I don't know how RE's splitting it though. That's not obvious, but I'll assume it is. Okay, so IN's going to be, so this arc here has to be 100. IN has to be 100. IRK, which goes, oh, that's just an angle. Oh, that's an arc. Wait, what? That's weird because R is a center. I think they meant to say, yeah, the measure of angle IRK. That's stupid. That's 50 degrees.
It's It's 90.
Because the arc is 50. Because the arc's 50, that's why. And then KEN, let's measure that arc of KEN. 210, because you have 90, 90, and 30, right? So 210. Or 180 plus 30 is fine. And again, IN was 100 degrees. Sure, yeah. Okay. Hope that's okay. And the delta map is short. I try to be mindful about that. 6 categories, 3 questions each, and it's like this kind of stuff. So should be okay. All right. Why don't you guys try this one? And actually, let me make sure the labels are fine. So BTI, that's an angle, good. BTE, that's an angle, good. TEB, that's an angle, okay. And measure of arc BI is 40 degrees. Okay, go and try that. I'll be right back.
Oh, that's 40.
Sorry, not too bad. And I got a print from you, 31. Okay, let's go through these answers in a moment. See here. Oh, I'm gonna just the top part. Give me a sec. Okay, this is gonna be I gotta do 30 copies. Cool. All right. Yeah, so let's talk about it. Yeah, so if that's 40 degrees at arc, then BTI is also 40 degrees. And then if that's 40, how much is left for BTE, guys? How much left over? Awesome. Very good. Very nice. And what kind of triangle is triangle BET? Well, it's isosceles, of course. And it's also obtuse if you wanted to get a little more specific. That's good. And measure angle TEB, because you have an isosceles triangle and 140 is the big angle, how much is left for the two smaller ones? 20 each, right? So it'll be 20 each. Good. All right, let's keep moving. If you guys already got to these, that's great, but let's just talk about these here. Then I'll talk about the proof at the end. We'll just do it as a paragraph proof, and then we'll be done for notes today, and you guys can do Delta Math. And Schoology is updated with all the assignments with the right dates and everything, so that is done correctly. That I know. All right, so measure BET again. That's 15 degrees. So this right here is 15 degrees. And BI, of course, we want to find that. Well, if that's 15, then that's 15, right? And if that's 15, 15, then what's this going to be? 150. Therefore, what's this going to be? And the arc has to be 30. So it's kind of like, once one domino falls, all the other dominoes fall, right? So
Why can we assume that the angle B is 50?
you have an isosceles triangle. We have two sides are the same, the angles are the same. How do you know it's isosceles? Radii. They're both radius. They both come from the center. So because that's the whole definition of circle, right? It's a set of all points equidistant from a fixed point. And that's what's happening here. Okay, next up. If you have a tangent, what do we know automatically is a tangent? Perpendicular, very good. So that's 90. RT is, of course, 4. AS, of course, is 6. But if AS is 6, what's AR? 6 as well. So you have, so if that's 10, so ATB has a hypotenuse of 10. What else do we know? It is. That's correct. So how long is TB then? 8, using Pythagorean theorem. So BT is 8. Easy. Yeah, let's talk about it. Okay, so BR. Yeah. How do I do it? Yeah. Yeah. So here's what's happening. We want this arc. So I'll do in red to have a little contrast. So we want this, right? Well, it intercepts, or it's intercepted by angle RAB. So arc RB, this is very important, by the way, is intercepted, means it's caught by it, is intercepted by angle RAB. So angle RAB defines arc RB. Okay. Now what does angle RAB equal? I don't know. We have to use SOHCAHTOA, correct. We have to use SOHCAHTOA. We have no choice. We have to use our trig knowledge. So when you guys ask me, oh, stuff from last semester, like it's hard for me to answer that question because I can't say no. Because yes, you do need to know trig, but of course it's things that have been reinforced. Again, little trivial stuff we don't do from the fall and the spring final. But this, yeah, you need to know it. And you could do a few ways. It's up to you. I could say tangent of A equals 8/6. Or you use sine or cosine. I don't care. It's your choice. But whichever one you use, you have to use the proper inverse trig function. So I got to do the inverse tan of 8/6. And that's where I have to use my calculator to work it out. And I think it's like 50 points. Someone could work that out for me, please. What's
53.1.
that makes sense. 53.1 degrees. And so if angle A or angle RAB or TAB, whatever, is 53.1 degrees, then arc is also 53.1 degrees. One decimal place is fine. Yeah. Yeah, go Faith. Yeah.
Let's say like one's acting for like specific like length or arc length or something like that.
If you see measure, it means no arc length. I would have to explicitly say in those words.
Okay.
You know what? I think I'll just even just tell you, find me the measure of the arc. I could do that. That's fine. It's not a problem. So 360 minus 53.1, what's that gonna be? 306.9, I think. Is that right? Yeah. It's close to 307, but 306.9 if we round to, yeah. Okay, so yeah, I mean that should be pretty reasonable, right? But a little bit of extra work we had to do. We had to do some trick. Does that make sense? How I went about that problem? Okay, cool. Now let's just talk about the last part, and then you guys can do delta math for the rest of the class. Yeah, you have plenty of time. You can totally knock this out, and then I'll produce a proper homework 31 if you haven't done it yet. Actually, it's printing right now, so I'll pick it up when I'm done. I'm gonna tear it off because I'll take care of it. I got very good at tearing it off just a few minutes ago. All right, so WZ is diameter, great. O is the center, great. OX is parallel to ZY, okay, cool. But if these are parallel, what does that mean about these two angles? Yeah, WOX and OZY are the same angle. Yeah, we know that. And then prove that WX is supposed to be arc. Arc WX is congruent to arc XY. Okay. Let me think about this one here. Okay. So those are the same. Those are the same. We have two radii. I also know that this angle is the same as all the other angles because you have two radii. And what else do I know?
You know that like the bottom. You know, it's split in half. Like.
OX. Oh yeah, I do know that WX is be the same as ZY. Oh yeah, I also know.
You know that.
Let me clear this.
All of the signs of WX and ZY are the two, their radius, so they're the same. They're on something. Well,
So I know that.
Oh, yeah, yeah.
I also know. Oh, I know this. I know these are the same. But let me. Those are the same. Why? How do I know those are the same? Alternate triangles. No, but I'd say I would do this, right? Because you have alternate two angles are the same. And if that's true, and I do know that this angle is the same as this angle. So this angle is the same as this angle. And also this angle is the same as that angle. So therefore, if these two angles, WOX and XOY are the same, the arcs are also the same. Okay, let me write this out now. Now that I understand it, I can write it out for you guys. So here's the deal. Given that OX is parallel to ZY, then angles XOY and OYZ are congruent due to them being alternate interior angles. They have a case. You know how like the centering pair was like people were laughing? That was my E period yesterday. They just kept laughing. They just had like this laughing fit. It was so weird. I did, but they still want to stop. They were still like giggling. Yeah. Come to Jesus.
I was saying because like period B had like
No, they
really
understood
good
that
on the test period.
they understand what they have to do, but just anyhow. All right. So let's have a little humility. Come on. All right. So anyway, XOY and OYZ, they're the same, right? This sure they did do that, yeah. Okay. Okay. Now next up. Okay. So next up, I also know that angles OZY and OYZ are congruent because they represent opposite sides. Because they are opposite, sorry. So next up, we know this is true, right? OYZ and OZY, because OZY is opposite what side? This one right here, right? OYZ is opposite what side? This right here. And aren't OZ and OY the same? Okay, the second paragraph. Do you see why the second paragraph's true? OYZ and OZY. I have it labeled. They're opposite, they're opposite congruent sides.
It makes sense, but like I don't know if I would be able to write it out and put it myself. Yeah, I
Okay.
I know that they're both radiuses, maybe and I saw from the end.
It's okay. I want you to sort of just, it's okay. You'll have a chance to practice this. But I'm sorry. So OY and OZ are both the same, right? Because they're both radii. SAS. What triangles are you saying? We're not talking about triangles. We're just talking about angles.
But how do you like prove that they're just like
How-
you have enough? You have essay.
all I want right now is to prove the angles are the same. You'll see in a moment why I'm doing that. Yeah. Okay. Next up, angles WX and OZY are congruent because they are corresponding angles for the parallel lines. So where are my parallel lines here? They already told us, right?
Alright.
So then these are corresponding angles. Because if you extend it, you see that, right? So those two angles have to be the same. So here's the deal. If OYZ is the same for both the first two paragraphs, right? And so these link up, right? And these link up. Then what does that tell me about XOY and WX? So what does that tell me about these? I'll do pink here. Oh, yikes. There we go. Yeah. So if OYZ is the common angle for the first two statements we made, OZY is the common angle for the second and third statements we made. What does that tell me about XOY and WX? They're gonna be congruent. It's all by substitution. So WOX is congruent to XOY by substitution. Correct. So therefore, arc WX, which is opposite WX, arc XY, which is opposite XOY, because they come from congruent angles. Correct, right. So that's how you would talk it out. I didn't want to do a formal proof because that could have been really long and nasty. I just felt, let's just talk about it. So again, starting from the top, OX is parallel to ZY, XOY and OYZ are the same because those are alternate triangles. OZY, OYZ, they're part of an isosceles triangle where the radii are the same, OY and OZ, so we know those are the same. Then fine, hold on, great. Then WX and OZY, those are corresponding angles, again, part of parallel lines. So by substitution, we realize that WX and XY are the same, therefore the arcs opposite are the same. So really it's just more of a logical flow thought process, the way I really care about. So this question. Cool. All right. Okay, cool. So if you guys go to Schoology, you guys can work on Delta Math. Go to homework 32, the link is there. Or just open up Delta Math, it should show up right away. You can knock this out totally in the next 15 or so minutes. So you have that done. Let me go pick up homework 31, so you guys have access to that, and I'll rip off the wrong homework 31s in the other packet. And that's it. We're all done. Yeah. I do. Yeah. Yeah, I'll take care of it.